Cloud seeding, a form of weather modification, is the attempt to change the amount or type of precipitation that falls from clouds, by dispersing substances into the air that serve as cloud condensation or ice nuclei, which alter the microphysical processes within the cloud. The usual intent is to increase precipitation, but hail and fog suppression are also widely practiced in airports. Cloud seeding also occurs due to ice nucleates in nature, most of which are bacterial in origin. Methodology: the most common chemicals used for cloud seeding include silver iodide, potassium iodide and dry ice. Liquid propane, which expands into a gas, has also been used. This can produce ice crystals at higher temperatures than silver iodide. The use of hygroscopic materials, such as table salt, is becoming more popular after promising research. Cloud seeding to increase snowfall is done when temperatures within the clouds are between 19 and 4 degrees Fahrenheit. Introduction of a substance such as silver iodide, which has a crystalline structure similar to that of ice, will induce freezing nucleation. Dry ice or propane expansion cools the air to such an extent that ice crystals can nucleate spontaneously from the vapor phase. Unlike seeding with silver iodide, this spontaneous nucleation does not require any existing droplets or particles because it produces extremely high vapor supersaturations near the seeding substance. However, the existing droplets are needed for the ice crystals to grow into large enough particles to precipitate out. In mid-latitude clouds, the usual seeding strategy has been based on the fact that the equilibrium vapor pressure is lower over ice than over water. The formation of ice particles in supercooled clouds allows those particles to grow at the expense of liquid droplets. If sufficient growth takes place, the particles become heavy enough to fall as precipitation from clouds that otherwise would produce no precipitation. This process is known as static seeding. Seeding of warm season or tropical cumulonimbus clouds seeks to exploit the latent heat released by freezing. This strategy of dynamic seeding assumes that the additional latent heat adds buoyancy, strengthens updrafts, ensures more low-level convergence, and ultimately causes rapid growth of properly selected clouds. Cloud seeding chemicals may be dispersed by aircraft or by dispersion devices located on the ground. For release by aircraft, silver iodide flares are ignited and dispersed as an aircraft flies through the inflow of a cloud. When released by devices on the ground, the fine particles are carried downwind and upward by air currents after release. An electronic mechanism was tested in 2010, when infrared laser pulses were directed to the air above Berlin by researchers from the University of Geneva. The experimenters posited that the pulses would encourage atmospheric sulfur dioxide and nitrogen dioxide to form particles that would then act as seeds. Effectiveness: cloud seeding is no longer considered a fringe science, and is considered a mainstream tool to improve rain precipitation and snow. New technology and research have produced reliable results that make cloud seeding a dependable and affordable water supply practice for many regions. While practiced widely around the world, the effectiveness of cloud seeding is still a matter of academic debate. In 2004, the National Research Council released a report stating that to date, there is still no convincing scientific proof of the efficacy of intentional weather modification. Referring to the 1903, 1915, 1919, 1944, and 1947 and weather modification experiments, the Australian Federation of Meteorology discounted rain-making. By the 1950s, the CSIRO division of radiophysics switched to investigating the physics of clouds and had hoped by 1957 to better understand these processes. By the 1960s, the dreams of weather-making had faded only to be reignited post-corporatization of the Snowy Mountains scheme in order to achieve above-target water. This would provide enhanced energy generation and profits to the public agencies that are the principal owners. Cloud seeding has been shown to be effective in altering cloud structure and size and in converting supercooled liquid water to ice particles. The amount of precipitation due to seeding is difficult to quantify. A key challenge is in discerning how much precipitation would have occurred had clouds not been seeded. Overall, there is general expectation that winter cloud seeding over mountains will produce snow, expressed by professional organizations. There is statistical evidence for seasonal precipitation increases of about 10% with winter seeding. Clouds were seeded during the 2008 Summer Olympics in Beijing using rockets, so that there would be no rain during the opening and closing ceremonies, although others dispute their claims of success. A 2010 Israel University study claimed that the common practice of cloud seeding to improve or induce rainfall, with materials such as silver iodide and frozen carbon dioxide, were not as effective as was hoped. A 2011 study suggested that airplanes may produce ice particles by freezing cloud droplets that cool as they flow around the tips of propellers, over wings or over jet aircraft, and thereby unintentionally seed clouds. This could have potentially serious consequences for particular hailstone formation. Impact on environment and health. With an NFPA 704 health hazard rating of 2, silver iodide can cause temporary incapacitation or possible residual injury to humans and mammals with intense or continued but not chronic exposure. However, there have been several detailed ecological studies that showed negligible environmental and health impacts. The toxicity of silver and silver compounds was shown to be of low order in some studies. These findings likely result from the minute amounts of silver generated by cloud seeding, which are 100 times less than industry emissions into the atmosphere in many parts of the world, or individual exposure from tooth fillings. Accumulations in the soil, vegetation, and surface runoff have not been large enough to measure above natural background. A 1995 environmental assessment in the Sierra Nevada of California and a 2004 independent panel of experts in Australia confirmed these earlier findings. Cloud seeding over Kosciuszko National Park, a biosphere reserve, is problematic in that several rapid changes of environmental legislation were made to enable the trial. Environmentalists are concerned about the uptake of elemental silver in a highly sensitive environment affecting the pygmy possum among other species as well as recent high-level algal blooms in once pristine glacial lakes. Research 50 years ago and analysis by the former Snowy Mountains Authority led to the cessation of the cloud seeding program in the 1950s with non-definitive results. Formally, cloud seeding was rejected in Australia on environmental grounds because of concerns about the protected species, the pygmy possum. Since silver iodide and not elemental silver is the cloud seeding material, the claims of negative environmental impact are disputed by peer-reviewed research as summarized by the International Weather Modification Association. History. Vincent Schaefer discovered the principle of cloud seeding in July 1946 through a series of serendipitous events. Following ideas generated between himself and Nobel laureate Irving Langmuir while climbing Mount Washington in New Hampshire, Schaefer, Langmuir's research associate, created a way of experimenting with supercooled clouds using a deep freeze unit of potential agents to stimulate ice crystal growth, that is, table salt, talcum powder, soils, dust and various chemical agents with minor effect. Then one hot and humid July 14, 1946, he wanted to try a few experiments at General Electric's Schenectady Research Lab. He was dismayed to find that the deep freezer was not cold enough to produce a cloud using breath air. He decided to move the process along by adding a chunk of dry ice just to lower the temperature of his experimental chamber. To his astonishment, as soon as he breathed into the deep freezer, a bluish haze was noted, followed by an eye-popping display of millions of microscopic ice crystals, reflecting the strong light rays from the lamp illuminating a cross-section of the chamber. He instantly realized that he had discovered a way to change supercooled water into ice crystals. The experiment was easily replicated and he explored the temperature gradient to establish the A40 degree Celsius limit for liquid water. Within the month, Schaefer's colleague, the noted atmospheric scientist Dr. Bernard Vonnegut, is credited with discovering another method for seeding supercooled cloud water. Vonnegut accomplished his discovery at the desk, looking up information in a basic chemistry text and then tinkering with silver and iodide chemicals to produce silver iodide. Together with Professor Henry Chesson, SUNY Albany, a crystallographer, he co-authored a publication in Science magazine and received a patent in 1975. Both methods were adopted for use in cloud seeding during 1946 while working for the General Electric Corporation in the state of New York. Schaefer's altered a cloud seed budget, Vonnegut's altered formative crystal structure, an ingenious property related to a good match in lattice constant between the two types of crystal. The first attempt to modify natural clouds in the field through cloud seeding began during a flight that began in upstate New York on November 13, 1946. Schaefer was able to cause snow to fall near Mount Greylock in western Massachusetts, after he dumped 6 pounds of dry ice into the target cloud from a plane after a 60-mile easterly chase from the Schenectady County Airport. Dry ice and silver iodide agents are effective in changing the physical chemistry of supercooled clouds, thus useful in augmentation of winter snowfall over mountains and under certain conditions, and lightning and hail suppression. While not a new technique, hygroscopic seeding for enhancement of rainfall in warm clouds is enjoying a revival, based on some positive indications from research in South Africa, Mexico, and elsewhere. The hygroscopic material most commonly used is table salt. It is postulated that hygroscopic seeding causes the droplet-size spectrum in clouds to become more maritime and less continental, stimulating rainfall through coalescence. From March 1967 until July 1972, the U.S. military's Operation Popeye cloud seeded silver iodide to extend the monsoon season over North Vietnam, specifically the Ho Chi Minh Trail. The operation resulted in the targeted areas seeing an extension of the monsoon period an average of 30 to 45 days. The 54th Weather Reconnaissance Squadron carried out the operation to make mud, not war. One private organization that offered, during the 1970s, to conduct weather modification was Irving P. Crick and Associates of Palm Springs, California. They were contracted by the Oklahoma State University in 1972 to conduct such a seeding project to increase warm cloud rainfall in the Lake Kyle-Blackwell watershed. That lake was, at that time, the primary water supply for Stillwater, Oklahoma, and was dangerously low. The project did not operate for a long enough time to show statistically any change from natural variations. However, at the same time, seeding operations have been ongoing in California since 1948. An attempt by the United States military to modify hurricanes in the Atlantic basin using cloud seeding in the 1960s was called Project Storm Fury. Only a few hurricanes were tested with cloud seeding because of the strict rules that were set by the scientists of the project. It was unclear whether the project was successful. Hurricanes appeared to change in structure slightly, but only temporarily. The fear that cloud seeding could potentially change the course or power of hurricanes and negatively affect people in the storm's path stopped the project. Two federal agencies have supported various weather modification research projects, which began in the early 1960s, the United States Bureau of Reclamation and the National Oceanic and Atmospheric Administration. Reclamation sponsored several cloud seeding research projects under the umbrella of Project Skywater from 1964 to 1988, and NOAA conducted the Atmospheric Modification Program from 1979 to 1993. The sponsored projects were carried out in several states and 2 countries, studying both winter and summer cloud seeding. More recently, Reclamation sponsored a small cooperative research program with 6 western states called the Weather Damage Modification Program, from 2002 to 2006. Funding for research in the United States has declined in the last 2 decades. The Bureau of Reclamation sponsored a 6-state research program from 2002 to 2006, however, called the Weather Damage Modification Program. A 2003 study by the United States National Academy of Sciences urges a national research program to clear up remaining questions about weather modification's efficacy and practice. In 1978, an estimated 2,740 metric tons of silver were released into the U.S. environment. This led the U.S. Health Services and EPA to conduct studies regarding the potential for environmental and human health hazards related to silver. These agencies and other state agencies applied the Clean Water Act of 1977 and 1987 to establish regulations on this type of pollution. In Australia, CSIRO conducted major trials between 1947 and the early 1960s, 1947 AA Euro 1952, CSIRO scientists dropped dry ice into the tops of cumulus clouds. The method worked reliably with clouds that were very cold, producing rain that would not have otherwise fallen. 1953 AA Euro 1956, CSIRO carried out similar trials in South Australia, Queensland and other states. Experiments used both ground-based and airborne silver iodide generators. Late 1950s and early 1960s, cloud seeding in the Snowy Mountains, on the Cape York Peninsula in Queensland, in the New England district of New South Wales, and in the Warragamba catchment area west of Sydney. Only the trial conducted in the Snowy Mountains produced statistically significant rainfall increases over the entire experiment. Thailand started a rain-making project in the late 1950s. The first principle was to scatter sea salt to catch the humidity in the air and dry ice to condense the humidity to form clouds. The project took about 10 years of experiments and refinement. The first field operations began in 1969 above Khor Yai National Park. Since then rainmaking has been successfully applied throughout Thailand and neighboring countries. On October 12, 2005 the European Patent Office granted to Kingbumibol Adjiliage the patent EP1491088 weather modification by Royal Rainmaking Technology. An Austrian study to use silver iodide seeding for hail prevention ran during 1981 Euro 2000, and the technique is still actively deployed there. Uses worldwide, Asia, the largest cloud seeding system in the world is that of the People's Republic of China, which believes that it increases the amount of rain over several increasingly arid regions, including its capital city, Beijing, by firing silver iodide rockets into the sky where rain is desired. There is even political strife caused by neighboring regions that accuse each other of stealing rain using cloud seeding. About 24 countries currently practice weather modification operationally. China used cloud seeding in Beijing just before the 2008 Olympic Games in order to clear the air of pollution, but there are disputes regarding the Chinese claims. In February 2009, China also blasted iodide sticks over Beijing to artificially induce snowfall after 4 months of drought, and blasted iodide sticks over other areas of northern China to increase snowfall. The snowfall in Beijing lasted for approximately 3 days and led to the closure of 12 main roads around Beijing. At the end of October 2009 Beijing claimed it had its earliest snowfall since 1987 due to cloud seeding. In Southeast Asia, open burning produces haze that pollutes the regional environment. Cloud seeding has been used to improve the air quality by encouraging rainfall. In India, cloud seeding operations were conducted during the years 1983, 1984 Euro 87, 1993-94 by Tamil Nadu GOVT due to severe drought. In the years 2003 and 2004 Karnataka government initiated cloud seeding. Cloud seeding operations was also conducted in the same year through US-based Weather Modification Incorporated in the state of Maharashtra. In 2008, there are plans for 12 districts of state of Andhra Pradesh. In the United Arab Emirates, cloud seeding is being conducted by the weather authorities to create artificial rain. The project, which began in July 2010 and cost $11 million, has been successful in creating rainstorms in the Dubai and Abu Dhabi desert. In Jakarta, due to frequent occurrence of flood in wet season, cloud seeding also used as an anticipation, according to Agency for the Assessment and Application of Technology. On June 20, 2013, Indonesia said it will begin cloud seeding operations following reports from Singapore and Malaysia that smog caused by forest and bush fires in Sumatra have disrupted daily activities in the neighboring country. On June 25, 2013, hailstones were reported to have fallen over some parts of Singapore. Despite NEA denials, some believe that the hailstones are the result of cloud seeding in Indonesia. North America, in the United States, cloud seeding is used to increase precipitation in areas experiencing drought, to reduce the size of hailstones that form in thunderstorms, and to reduce the amount of fog in and around airports. In the summer of 1948, the usually humid city of Alexandria, Louisiana, under Mayor Carl B. Close, seeded a cloud with dry ice at the municipal airport during a drought. Quickly 0.85 inches of rainfall occurred. Cloud seeding is occasionally used by major ski resorts to induce snowfall. 11 western states and 1 Canadian province have ongoing weather modification operational programs. 1. In January 2006, an $8.8 million cloud seeding project began in Wyoming to examine the effects of cloud seeding on snowfall over Wyoming's Medicine Bow, Sierra Madre, and Wind River mountain ranges. A number of commercial companies offer weather modification services centered on cloud seeding. The U.S. signed an international treaty in 1978 banning the use of weather modification for hostile purposes. During the 60s, Irving P. Crick and Associates operated a successful cloud seeding operation in the area around Calgary, Alberta. This utilized both aircraft and ground-based generators that pumped silver iodide into the atmosphere in an attempt to reduce the threat of hail damage. Ralph Langeman, Lynn Garrison, and Stan McLeod, all ex-members of the RCAF's 403 Squadron, attending the University of Alberta, spent their summers flying hail suppression. The Alberta Hail Suppression Project is continuing with $3 million Canadian a year in funding from insurance companies to reduce hail damage in southern Alberta. Europe, cloud seeding began in France during the 1950s with the intent of reducing hail damage to crops. The ANILFAR project consists of local agencies acting within a non-profit organization. A similar project in Spain is managed by the Consorcio por la Lucha ante Granizo de Aragon. The success of the French program was supported by insurance data. That of the Spanish program in studies conducted by the Spanish Agricultural Ministry. The Soviet Union created a specifically designed version of the Antonov An-30 aerial survey aircraft, the An-30M Sky Cleaner, with 8 containers of solid carbon dioxide in the cargo area plus external pods containing meteorological cartridges that could be fired into clouds. Soviet military pilots seeded clouds over the Belarusian SSR after the Chernobyl disaster to remove radioactive particles from clouds heading toward Moscow. At the July 2006 G8 summit, President Putin commented that Air Force jets had been deployed to seed incoming clouds so they rained over Finland. Rain drenched the summit anyway. In Moscow, the Russian Air Force tried seeding clouds with bags of cement on June 17, 2008. One of the bags did not pulverize and went through the roof of a house. In October 2009, the mayor of Moscow promised a winter without snow for the city after revealing efforts by the Russian Air Force to seed the clouds upwind from Moscow throughout the winter. In Germany, civic engagement societies organize cloud seeding on a region level. A registered society maintains aircraft for cloud seeding to protect agricultural areas, for example in wine-growing areas, in the district Rosenheim, the district Miesbach, the district Traunstein and the district Kufstein. Another society for cloud seeding operates in the district of Villingen-Schwenningen. Australia. In Australia, the activities of CSIRO and Hydro Tasmania over central and western Tasmania between the 1960s and the present day appear to have been successful. Seeding over the Hydroelectricity Commission catchment area on the Central Plateau achieved rainfall increases as high as 30% in autumn. The Tasmanian experiments were so successful that the Commission has regularly undertaken seeding ever since in mountainous parts of the state. In 2004, Snowy Hydro Limited began a trial of cloud seeding to assess the feasibility of increasing snow precipitation in the Snowy Mountains in Australia. The test period, originally scheduled to end in 2009, was later extended to 2014. The New South Wales Natural Resources Commission, responsible for supervising the cloud seeding operations, believes that the trial may have difficulty establishing statistically whether cloud seeding operations are increasing snowfall. This project was discussed at a summit in Narrabri, NSW on December 1, 2006. The summit met with the intention of outlining a proposal for a 5-year trial, focusing on northern NSW. The various implications of such a widespread trial were discussed, drawing on the combined knowledge of several worldwide experts, including representatives from the Tasmanian Hydro Cloud Seeding Project, however does not make reference to former cloud seeding experiments by the then Snowy Mountains Authority, which rejected weather modification. The trial required changes to NSW environmental legislation in order to facilitate placement of the cloud seeding apparatus. The modern experiment is not supported for the Australian Alps. In December 2006, the Queensland Government of Australia announced a $7.6 million in funding for warm cloud seeding research to be conducted jointly by the Australian Bureau of Meteorology and the United States National Centre for Atmospheric Research. Outcomes of the study are hoped to ease continuing drought conditions in the state's southeast region. Africa. In Mali and Niger, cloud seeding is also used on a national scale. Conspiracy theories. Cloud seeding has been the focus of many theories based on the belief that governments manipulate the weather in order to control anything from global warming, populations, and military weapons testing, to public health. See also, artificial cloud, atmospheric moisture extraction, bioprecipitation, chemtrail conspiracy theory, Project Cumulus, Project Popeye. References, notes. Bibliography. Schaefer, Vincent J. Serendipity and Science, My 20 Years at Langmuir University 2013, compiled and edited by Don Rittner. Square Circle Press, Voorheesville, NYISBN 978-0-956,926-3-6, Note. Chapter 6 The War Ends as I Discover Cloud Seeding. Schaefer discusses the conversations with Langmuir while climbing Mount Washington and then describes the event My Discovery of Dry Ice Seeding on pages 128 to 129. References by his son, James M. Schaefer, Ph.D. June 24, 2013. External links, Rainmaking in China, Nevada State Cloud Seeding Program, European Patent EP 1491088 Weather Modification by Royal Rainmaking Technology.